Hello and welcome to week 3. This week we're going to be investigating numeration systems. So our objectives this week are to develop number systems using patterns, explore ancient number systems. We're going to practice developing community with our classmates. Last week we did it through our team assignment. This week we're going to be doing it through our discussion board. We're also going to be developing the idea of place value, major features of number systems we're going to explore, major features of the base 10 number system. We're going to develop rounding rules, and we're going to compose and decompose numbers. The math practices we'll really focus on this week is MP2, reason abstractly and quantitatively, MP3, construct viable arguments and critique the reasoning of others, and MP7, look for and make use of structure. We are always practicing all of the math practices, but these are the ones that are highlighted this week. MP1 is also vital, making sense of problems and persevering in solving them. So for warm-up, I just want to do a little review of last week. So were these patterns arithmetic, geometric, or neither, and explain how you know. So you can pause the video for a minute and then check your answers when you're done. Hopefully your answers match these. The first pattern was geometric because there's a common ratio of 2. For example, if we took the second term and put it over the first term, 10 divided by 5 is 2, or 20 divided by 10 is 2, or 40 divided by 20 is 2. The second pattern is arithmetic because there's a common difference of 4. So between each two successive terms, there's a common difference of 4. So that was just a reminder of last week. So this week, you're getting ready to go on an adventure. So it's your passport to adventure. We're going to explore numeration systems: Babylonian, Egyptian, Mayan, Roman, and Hindu Arabic. So there's an assignment on Canvas called Numeration Systems that you should complete as soon as possible. It's kind of long and it may be a little challenging. So let me tell you a little background. The purpose of your trip is to study each numeration system, discover what symbols are used and what each symbol represents, use inductive reasoning to form patterns about each system, and convert numbers written in each system to Hindu Arabic, which is our base 10 system we use today. So you can go to the Canvas assignment. You need to click on the Google Doc and it will force you to make a copy. And then there's Google Slides that you will follow along and complete the activity. Just so you know, I did include some additional resources for the different number systems, so you can take a look at these if you're really struggling on assignments throughout this week. So after you're done with that, you might have been thinking as you were going, what base is each number system working in? Well, we work in the Hindu Arabic number system, which is our base 10 system. This is the system we use today. This should look very familiar. This is our base 10 number system, and these are our place values. And every 3 place values is a period. So notice that we're on base 10. So when you see 10 to the 0, the base is 10, the exponent is 0, and it goes up accordingly from the left. That numeration systems activity on Canvas, you can make a foldable. So you need 3 sheets of paper, preferably different colors. You're going to cut out all the systems. There's a link to those right on there. And then you're going to fold those 3 pieces of paper, leaving about an inch tab for each system. You're going to staple them in the middle, and then you're going to write down all the important stuff. This is a great way to quiz yourself just on, do I remember anything about these number systems? And then don't forget to add it to your interactive notebook and update your table of concepts. So next, we're going to dive into a B4 candy factory. If you read through the presentation page, you know that we're going to use a candy analogy to investigate different base systems. So you can click on that linked handout and have that with you, and that will really help you on the different place values assignment. So the rules of a B4 candy factory. Candy is packaged in the following ways. There are unit boxes that hold 1 piece of candy each, long boxes that hold 4 pieces of candy each, flat boxes that hold 16 candies each, and cartons which hold 64 candies each. Personally, I would like the 64 candies. Don't send me the unit box, right? All right, the B4 Corporation uses the fewest number of boxes when they're packaging a chocolate order and make sure that every box is filled to capacity. So they wouldn't ship out a flat box if it didn't have all 16 candies in it. Notice that the B4 Corporation's boxes would be different from a B10 candy factory or a B2 candy factory. So the way they record quantities is also different. So the numeral 12 B4 stands for 1 long box and 2 unit boxes. So 6 candies fit in those boxes. The numeral 203 B4 stands for 2 flat boxes, no long boxes, and 3 unit boxes, which would be a total of 35 chocolate candies. Make sense of that before you move on, because it's really important that you don't call that 12 and you don't call that 203, because that would be base 10, and we're not in base 10. We're in B4. So right here, this 1 is actually 4 candies, and then these unit boxes each hold 1 candy. So that's how we get 6 candies. Over here, these flats each hold 16 candies. So 16 plus 16 is 32. Then 1, 2, 3. So 35 candies. So we read that as 203 base 4. Let's work some more. You get a memo to package the following candies for the B4 Corporation. So you're going to try this. So here's the memo. This is really good practice for your B2 discussion board this week. So here's the memo. It says, urgent today, please package 31B4 candies for Susie's gift shop. So it says, make a sketch of what the numerals mean in terms of which boxes are used for packaging chocolate candies for the B4 Corporation, and then how many candies are being shipped each time. So think about what you would draw right here for your candy boxes. And it's really helpful if you just use a square for flats, if you use a line for longs, and if you use an X for units. Because if you keep trying to draw all those rectangles, it's very time consuming and it doesn't look very consistent. Same thing on the second memo. Next, this time we're packaging 1201 B4 for Billy Bonka's candy shop. So draw a picture, what it would look like in the candy boxes from the page before, the slide before, and then write down how many candies that is. So pause the video, try it, because you're going to have to do this when you do your B2 discussion board. Were you right? Let's see. So if you were doing the 31B4, that means 3 longs and 1 unit. So 3 longs, I drew 3 lines, and then 1 unit, which would be a total of 13 candies. Let's make sure we understand where that came from. Each one of these lines is 4, so 4, 8, 12, and this little 1 unit box is just 1 more, so that's 13. For Billy Bonka's, we did 1 carton, we did 2 flats, no longs, and 1 unit. So that's 64 candies in a carton, 16 in each of these, so 16 and 16 would be 32. So 64 plus 32 would be 96, plus 1 more is 97. So there's 97 candies in these. Really make sure you pause this video and make sense of what just happened, so you're not reading that as 1,201 candies, because it's not. It's only 97. And you can refer back to this when you're doing your memos on your B2 discussion board. All right, so let's talk about counting in base 4. So we're going to start up in this left-hand corner of this table, and we're going to add 1 unit at a time. And so say the number out loud and write the number in base 4. You have to regroup when you get to 4, right? Because we're in base 4, so we're going to go to the next size box. So, and then it says stop when you reach a flat, which would be this whole thing full. So we're going to go 1, 2, 3, and then right here, we're not going to write a 4, because think about your boxes. You would have 3 unit boxes, but once you get to that 4th candy, you can move over a column, and now you can use a long box. Okay? So you're placing these numbers as what it would look like to package each one of those boxes. Okay, so think of your boxes. So try this. fill in the whole table and then make sure you pause this video so then you can check your work on the next slide. Okay, how'd you do? Hey, anyone get something wrong? This last box right here, why isn't it 40B4? I want you to think of that. And remember, I don't read this as 100. I read it as 100B4. So see if you can figure out those candies and make sense of it. All right, now we're going to practice. So this is a table from that handout. On the far left, it has the number in base 10. So that's a regular number. That is a 38. You can call it 38. Down here, you can call this 267. Then you're going to sketch it, okay, using B4 packaging, okay? Then over here, you're going to write what the numeral is in B4 packaging. So notice that this one right here is 121B4. So I would draw 1 flat, 2 longs, and 1 unit. And then I would convert that and see what that is in base 10. So notice that in each line we have a different missing pieces. So in this one I gave you the base 10 number, you have to give the packages and the B4 number. Same thing on D, okay? On B and C, on B, the B4 number is given, so make sure you pay attention to that because you're going the other direction. And then in C, only the picture is given, but you should be able to figure out both your numeral in B4 as well as your how many candies that is in base 10. So take your time. This might take a few minutes, and then check your work on the very next slide. So how'd you do? The one that usually gets people is the last one because they went up and they thought, oh, I can just add another carton, but they can't because once you have 4 of anything, you have to move over a place value. So they had to make a new box to package candies in. And that box, you could call it a mega carton, you could call it a crate, you could call it whatever you want. And then you could draw a picture of what you think that would look like. But it's important to note that that holds 256 candies. Okay, so if you had a mistake, really correct that last one. So let's answer these following questions. The B4 Corporation uses the digits 0, 1, 2, 3 when they record how they're packaging chocolates. Why don't they use the digits 4, 5, 6, 7, 8, 9? Think of that base 4. What system would we be using if we were using 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9? Think about that. And then how are B4 and base 10 packaging systems similar? And then how are they different? This is a great time to pause, really reflect on what we've gone through so far in these slides before you move on. Here are some answers for you. Since every time you have 4 of any box, units, longs, flats, cartons, mega cartons, then you have to regroup into the next larger size packaging. So in the grouping systems, we wouldn't have those numbers, those digits 4 through 9. What system would we be using if we were using the digits 0 through 9? Well, that must be base 10 because there are actually 10 digits in that 0 through 9. Lastly, this one was a little more involved, so I reserved it for the next slide because there are some similarities and some differences between B4 and B10. So go through these similarities between the systems. So the similarities, the sizes of the place values are powers of the base number. So there's a relationship between place value that is related to the base number. So think about 10 to the 0 power, right, would be the units, or 4 to the 0 power would be the units. Okay? And it tells you there are digits that we use, and it's n, it's 0 through n minus 1. So for example, base 10, we go 0 through 9. So the n minus 1 is 10 minus 1. So in base 4, we go to 0 to 3 because 4 minus 1 is 3. So you could actually start to make some connections. What do you think base 2 would be? What digits would it use? Or base 5? Or base 7? Okay. 0 is also a really important number in the place value system because it can represent that it's 0 of those and it's a placeholder. So it's really important. Remember when you were studying those other number systems, not all of them had 0 as a symbol. So then it was hard to tell which place value you were in. So that's a really important thing. You also regroup and repackage when you've reached n of a certain place value. So when you get to 10, you repackage and move to the next one. When you reach 4 and base 4, you move to the next one. The value of a number is found by multiplying the face value, so that's the digit, times the place value, so that's how many candies. So in other words, the face value is the number of boxes, and the place value is how many candies per box. Okay, so you do that, and then you sum all those, the products. And the methods for writing the numbers are the same. You start with the largest possible place value, fill it, and work your way down. The difference is place values are different sizes, for sure. Repackaging happens at different amounts. Digits are used to write the numbers differently, and the recording of the number of chocolate candies in base 10 is different than the recording in base 4. So they do have similarities and differences. So face value versus place value. We just talked about this a little bit, but if you focus on it more, if we looked at the number 313B4, there's two digits that both have the same face value. They're both 3s, but they have a different place value. So the 3 means something different depending on its placement in a number. That's a really hard idea for kids to figure out. So what you should try to do, and what I have kids do in class, now I'm not teaching them base 4, we're just working on base 10, but they do a think, pair, share. So explain in your own words how the face value of each digit, so in other words, the number of boxes, and the place value of each digit, which is the number of candies in the box, contributes to the overall value of 3212B4. So in other words, that 2 that's in that first place on the far right doesn't mean the same value as the other 2. And there it is worked out for you. So the first 3 is in the 64th place, or it's 4 to the 0, 1, 2, 3. So it's 4 to the 3rd. Okay. And the 2 is in the 16th place. The 1 is in the 4th place. And the other one, and the last 2 is in the units place, or the ones place. So at this point, you should be able to do your Canvas assignment that's called different place values. It's not easy. This is hard stuff. You might have to watch this a couple times, but I've also given you a different assignment called exploding dots. And in exploding dots, it's going to do a similar discussion of different bases, but it uses a different analogy. Instead of candy boxes, it's using exploding dots. It's kind of like a game. A lot of students think it's very fun. So, and it clicks better with, for some people with exploding dots, for other people with Candy Factory. So you might want to do that before you do the different place values assignment. When you're doing exploding dots, make sure you read the directions because you have to take notes, but you also have to write down all your calculations, and you're uploading that to the assignment. Here's a quick check-in for you. How many candies are there in 312B4? How would you do that? You have to think about how those place values are. And what's the difference between the 2's and the number 232B4? Could you describe it in words? Could you explain it to someone? Now here's a flashback to week 1. Without looking at your notes, what is MP4? It's a good way to study. And lastly, back to week 1 as well, what is step 1 of Poya's 4-step problem-solving process? After you answer those, go ahead and move to the next part of the video so you can see the answers. All right, so 312B4 is actually 54 candies. How do I know that? Because I know the 2 is in the 4 to the 0 spot, or the units boxes. The 1 is in the 4 to the first spot, or the long boxes that contain 4 candies, and the 3 is in the flat boxes, which contain 16 candies each. So I would do 3 times 16, right, which is 3 times 16, which is 48, plus one group of 4, right? So 48 plus 4 is 52, plus 2 units is 54 candies. And then I give you a little explanation of what's the difference between the 2s. And then remember, modeling with mathematics is MP4, okay? And then understand the problem is the POYA first step. So, you're probably getting tired. You can pause the video. It's like 20 minutes right now. So now we're going to switch companies. Now we're in a base 10 candy factory. So we're going to use that same analogy for base 10 candies. So now our unit is 1, our long is 10, our flat is 100, and our carton is 1,000. Okay? So the rules are very similar to the B4 candy factory. Okay? So you're going to fill with the fewest boxes you could, and every box needs to be all the way full. Okay? So, and it gives you an example. If you were packaging 17 candies in a B10 candy factory, you would have 1 long box and 7 unit boxes. You couldn't do 17 unit boxes. Even though they're equivalent, you would probably get fired from the B10 candy factory. So this should be more familiar for you. This is the place value system that you're used to. So, and you can see that the 1s is 10 to the 0. Remember, anything raised to the 0 power is 1. And then 10 to the first is 10. 10 to the second is 100, and so on. So the power increases by 1 each time. We can relate that to other systems. Look at the base 7 system. The only thing different between base 10 and base 7 is the base in that expression. So instead of a 10, it's now a 7. So what do you think it looks like in base 2? This will really help you for your B2 candy factory. So try to write in those boxes before you go to the next part. There it is. I hope you got it right. All you had to do was replace the 7 with a 2. So 2 to the 0, then 2 to the first, then 2 to the second, and so on. So place value is a really complex system of representation that functions almost like a foreign language to a child that is also trying to use that system to learn other things. So if you think base 10 is easy, that's because you're super familiar with it. Students in your class, especially young elementary students like kindergarten and first grade, they really don't have those symbols connected to those numbers yet, so they don't quite get it. That's why I had you do other number systems, because I wanted you to feel that productive struggle and that frustration that your young elementary students feel when they're first learning numbers, that this symbol represents an 8, and what does an 8 mean? So here's some of the standards so you can see it. In kindergarten, they learn place value, so 11 through 19, and look how they talk about composition and decomposition. So you should be able to break down 18 into 10 plus 8. And so you could see that these are composed of different numbers. Okay, so that's in kindergarten. So composing versus decomposing. Think about combinations of 5 or 10. How many different ways can you compose 10? Why is it important for a kid to know this? And decomposing, breaking a number into 2 or more groups so that a combined amount is equivalent to the original amount. I don't know if you can see these, but these are linking cubes. A lot of kinder teachers use something like this to talk about composing and decomposing. For example, if I have 10 linking cubes here, and I'm asking that question of combinations of 10, a kid can really just go like this and see the combination of 10. It's a very concrete way to see 5 and 5 makes 10. And then, once they understand that, they'll start doing different combinations. So they'll say, oh, 9 and 1. And then we'll talk about the properties next week, 1 and 9. So reversing those so they can get a lot of them. And hands-on manipulatives are great. Expanded form. When we break down a number in elementary school, sometimes we just break it down like this. We first start out with just saying, okay, that's 700 plus 80 plus 2, but we really want them to start thinking of place value. So we want to say, okay, that's 7 times 100. Think about it's 7 boxes that each hold 100 candies, and then 8 boxes that hold 10 candies, and 2 boxes that hold 1 candy. So you can see that the base 10 unit is circled, or the size of the box, yes, is circled. You could even write it in exponential form. So this is place value form, and they show expanded form. You could write it right there as 2 times 10 squared plus 3 times 10 to the first plus 4 times 10 to the 0 power as well. So in the middle school grades, you might be more likely to do something like that. Let's look at the first grade standards. So they go a little further, and they talk about digits a little more specifically. Notice they still do 11 through 19, but they also do, okay, now we're going to do 10, 20, 30, 40, 50, so we can count that and make sense of what's in the tens and what's in the ones. Then in second grade, they start bundling things together. So now they can count in hundreds, fives, tens, and 100, and they can read and write numbers to 1,000 using base 10 numerals, number names, and expanded form. So you have an assignment this week about writing large numbers, and so we're kind of practicing those kinds of things. Have you ever thought about why we have rounding rules? That's a great question. You have an assignment on Canvas that's a rounding assignment that would be a great thing for you to do. I don't think it's too challenging. There's some videos that go along with it. So if you're really struggling with another assignment, that might be one, or the writing large numbers would be a great one to jump to. And that's it. Done and done. You finished week 3. Well, you finished the slides. So there's some big ideas here, and some of them might be challenging. Feel free to email me, schedule a time, drop in my office hours. I'm available for you. So make sure you come and you get the help you need. We're doing great. Keep it up.